AnyCubic are cracking out the big guns with their new Kobra S1 Max. This isn't just a larger version of the Kobra S1, their 2025 flagship. This has a list of new features and quality of life improvements packed in. I've been testing this pre-release unit for over a month now, and it's been a bit of an experience, so buckle in. Today we'll be looking at what it offers, how it actually performs in real-world use, and if this is the right printer for you. So, let's take a look. This is my first taste of modern generation AnyCubic printers, so I'll be coming at this from the perspective of someone new to the AnyCubic ecosystem, seeing how easy it is to adopt and use and how well it performs. Whilst AnyCubic did send me this pre-release unit, they have no control over what I say or do in this video, and as we'll see in a bit, there are some concerns we really need to address. Before we dive into how it performs, let's take a quick look at what the Kobra S1 Max is and what it offers. Whilst its curved exterior is smaller than many other recently released printers, much like a famed blue box, compared to them, it's bigger on the inside and houses a build volume of 350 by 350 by 350 millimeters. That's a larger build volume than the H2S and the same size as the K2 Plus, whilst wrapped in a smaller and sleeker package. As with most modern flagship releases, it's an enclosed Core XY design, and unlike its smaller S1 brother, the Kobra S1 Max features active chamber heating of up to 65 degrees, which combined with its 350 degrees Celsius nozzle should enable greater control when printing more specialized materials, something we'll look at a bit more later on. Unlike most printers where the purge chute is hidden around the back, on the S1 Max it's positioned on the left side. Not only does this allow for much more convenient access, it also reduces the overall required footprint of the printer. You'll still need to leave a gap at the back of the printer for the cables and the cooling vents, but this will reduce the size of the necessary gap, and as the purge chute is positioned beneath the external spool holder, it's utilising an area that you'd have needed to access anyway. This does theoretically limit the size of spools that you can fit here without blocking the chute, but these arms are usually only designed for 1 kilogram spools, and you'd likely want to use a dedicated stand if you were going to use a larger one anyway. The Kobra S1 Max has been somewhat future-proofed with its networking capabilities and features dual-band Wi-Fi 6, but more importantly it features an Ethernet port as standard, which isn't available on some competitors without paying for more premium or enterprise versions. Whilst it does come down to personal preference, a tweak that I appreciate that they've made since the S1 is that they've moved the screen down from sitting on top of the printer to fitted to the front. Whilst it still sticks up a little bit over the top, I feel a lot less concerned with this design that I'm going to accidentally snap it off, especially if I have a USB stick fitted which can act as a bit of an emergency buffer in case of clumsiness. Sitting on top of the S1 Max is AnyCubic's latest filament management system, the Ace 2 Pro. Not only does the Ace 2 Pro have a built-in filament dryer, but it can continue to dry the filament whilst you're actively printing, something we'll be looking at more in a bit. The Kobra S1 Max does feature an air filter chamber. However, whilst it technically comes with a carbon filter, it is literally just a bag. It isn't even made to measure and doesn't fill the chamber spacing, meaning that when air is blown through there, it will follow the path of least resistance, i.e. around the bag, not through it. AnyCubic has told me that their tests show that the air is circulated through the bag, but I am skeptical. This basically renders the filter pretty much useless in my opinion, though I've no doubt that soon after release there's going to be loads of designs popping up online for printable filter cartridges which will basically negate this issue, and I'd also hope that AnyCubic are going to eventually release a more dedicated filter cartridge for this at some sort of price. Whilst the filter cartridge does seem to have been a bit of an oversight, or it's just something that's lagging behind, there are some great inclusions on the S1 Max. The design for the built-in filament cutter is almost silent, a trait that we'll see seems a bit of a trend with this printer. It has a built-in camera for print failure detection, remote monitoring, and recording time lapses, though don't expect anything cinematic as this is a 720p camera with what seems to be quite low bitrate for streaming, but it should be more than good enough to keep an eye on your print in case something goes wrong. It also has dual auxiliary cooling fans for even more cooling, even lighting on both sides, print failure detection, object skipping, power failure recovery, and a pretty cool nozzle change system that we'll look at later. All of that packaged in what I feel is a pretty nice looking printer that's smaller than much of its similarly spec'd competition. So here we're looking at the Kobra S1 Max combo, which comes complete with a Ace 2 Pro, AnyCubic's latest filament management system. It's got cutouts both in the base and the lid which help keep the spools stable, not leaning to one side and not jumping around, though it's worth noting that these may restrict compatibility with some sizes and designs of spools. The Ace 2 Pro's built-in filament dryer can heat up to 65 degrees Celsius, and whilst monitoring the internal humidity level, will actively manage moisture by pumping out saturated air. As I mentioned earlier, the headline with the Ace 2 Pro is that it can dry filament whilst actively printing, and an extra little feature which I particularly like, so we'll look at that more in a bit. If we look around the back of the Ace 2 Pro, we find not just one PTFE tube coming out of it, but 4. When I first saw this design, I was definitely not sold on it, but having run it for a bit now, I can say that there's definitely method behind this madness, which we'll delve more into in a minute. At the risk of being petty, one little gripe that I've got with this is that the Ace 2 Pro comes with a particularly short power cable. Whilst it's intended to sit on top of the printer, when there, the power cable doesn't reach far beyond the base of the printer. Luckily, these are a type of standard kettle lead, so if you aren't using a conveniently placed extension cable, a longer lead will be a cheap and easy find. So that was a very quick overview of what the Kobra S1 Max has to offer, but before we delve into the specifics of some of the features, seeing how they perform along with some test prints, let's have a quick look at AnyCubic's slicing software. Whilst you can use other slicers with this printer, it's part of the user experience that you're buying into, and as with other printers, there are some features that are only going to work with first-party software. AnyCubic's latest slicer is called AnyCubic Slicer Next, and is a fork of the popular Orca slicer. Orca slicer itself is based on the open source Prusa slicer and is aesthetically very similar to Bamboo Studio. Because it's been built on the same framework, there is also a high level of cross-compatibility, and you're able to open 3MF project files created in Bamboo Studio, such as those downloaded from makerworld.com. It will then convert modifications and settings into AnyCubic Slicer Next equivalents, and items that have been pre-painted will remain painted. There can be some settings that don't translate when doing this, so make sure to address any issues it flags once imported to ensure that the instructions aren't misinterpreted or ignored when printing. On the whole, it offers many of the same tools and settings as the aforementioned slicers that you may be familiar with, including multi-plate projects, cut tools, text tools, measuring tools, and mesh boolean tools, albeit with some AnyCubic flavouring. When we go into the Workbench tab, we can view the status of our S1 Max printer. It gives us access to a live view of the camera, as well as various settings and controls. Whilst it's nice that when used on a large screen, you can get a large video feed that isn't locked to a specific size, unfortunately the layout dynamically changes with the size and shape of the slicer window, and when viewed on a smaller screen or a vertical screen can result in a very small view with no way to adjust or full screen it. The camera itself is very wide angle and shows more of the printer interior than some other printer cameras tend to. This can be great for monitoring larger prints where the lower half can, on some other printers, move beyond the camera's frame. The feed is 720p, so it's not the highest resolution unfortunately, and I have noticed some jello from the rolling shutter, but whilst it's not going to win any Oscars, it is good enough for troubleshooting and general monitoring of your prints. One feature advertised is the ability to estimate the amount of filament remaining on a spool. However, whilst this seems to work with spools that are automatically detected as AnyCubic via NFC tags, Not only does this not work with third-party filaments, but it also doesn't seem to work with any cubic spools that don't have NFC tags. Any filament that doesn't feature a tag is identified as having less than 10% left, even if it's a brand new and unused 1 kilogram spool. I tend not to take much notice of the filament remaining feature on any of my printers, as if I'm in the room, it's usually easier just to look at the spools themselves. The reason this is frustrating is, whilst it doesn't display the reading on the printer itself at all, in the slicer it affects the amount of filament shown in the graphic, meaning that there's only ever a 10% sliver of colour of which to see what the spool contains, which may be frustrating if you have similar colours loaded. I raised this issue with AnyCubic and they said they're both aware of it and working on it, so hopefully this is just a result of this being a beta unit and it'll be rectified by release. Either way, it should be a software issue and they'll hopefully patch it with a firmware update in the future at some point. Moving on to things that really matter, once you've got your model sliced, you have 3 printing options. You can export to G-code file, which will allow you to save to a USB stick and insert that into your printer. You can upload it to the cloud, which will allow you to start the print remotely later on, or you can select Remote Print, which will send the print directly to the printer via the cloud. It should in theory be pre-assigning each of the colours you have in your print to the most similar colour you have loaded of that material type. However, I have found on several occasions that even when I have the exact same colour loaded as I sliced for, it will default to a completely different colour. For example, when going to print something that's red and white, with red, white and black filaments loaded in the same material, it will pre-assign the black filament to the red part of the print. You can quickly just swap this over, and it doesn't happen every time, but it has been a little and unnecessary frustration. Once happy with your colours, as usual you can then turn on and off various settings to run before and during your print. This includes running pre-print calibrations like bed leveling and flow calibration, filming a time-lapse of the print, and using AI error detection to pause the print if errors are detected. What was really cool to see in this list of options here is resonance compensation or input shaping. Most modern printers have input shaping calibration, which is where it will detect the resonance of different motors at different frequencies, then compensate for that throughout the print. This is one of the innovations which has allowed significantly faster prints, giving significantly better results, all whilst remaining quieter. The catch is, this resonance compensation usually runs before each print begins and requires it to make some pretty loud resonance sounds. Not ideal if you want to start a print with someone sleeping next door. This setting allows you to choose. You can either run the calibration pre-print, ensuring it's best prepared for its current conditions, or you can forego the calibration, allowing for a quieter start to the print, and it will use the results from the previous calibration for this print. And then we have the drying options. This uses the Ace 2 Pro's built-in filament dryer to heat up and dry the filament. If we turn this on by selecting print while drying, it will heat up the filament to dry whilst actively printing. To prevent issues with the filament becoming more malleable whilst printing, it will dry at a lower temperature. Rather than to dry saturated filament, this mode is intended to help maintain relatively dry filament during a print. What is cool is you also have the option to print after drying. This means you can set it up to 65 degrees Celsius and it will dry the filament first, then after a set time it will stop heating and start printing. Now, we briefly saw earlier that the Ace 2 Pro has 4 PTFE tubes sticking out the back, which may be different to what you're used to seeing with other filament management systems which merge their 4 feeds internally into a single output. These 4 PTFE tubes run from the Ace 2 Pro down to a hub mounted on the back of the printer, which then merges them into a single input on the printer. This does mean you've got 4 times the amount of PTFE tubes to both route and maintain, though in theory it's the same amount of use divided across the 4 of them, meaning that even though you've got 4 PTFE tubes to eventually replace, each one should in theory last 4 times as long. It also means that, aided by the individual buffers, Each filament only needs to be retracted a short distance out the back of the printer when not in use, rather than needing to retract all the way back onto the spool. One of the things I quickly noticed when using this setup is how incredibly quiet the Ace 2 Pro is. When loading and unloading filament, it's so quiet you barely notice it's running. This is partly thanks to the internal design, but largely down to the slow speed that the motors run at. The time lost due to these slow running speeds is negated by the short distance the filament needs to travel, allowing to provide quick filament swaps whilst keeping the volume right down. When compared to other single nozzle printers, providing the flush volumes are the same, the overall filament change time of the S1 Max sits within the same ballpark, occasionally a few seconds slower, whilst remaining the quietest automated filament change I've ever heard. Another advantage of this multi-path filament routing method is that because there is a longer distance of filament that sits outside of the Ace 2 Pro whilst printing, if you're drying whilst printing, by the time the filament is loaded into the main extruder gear, it's unlikely to still be preheated, further reducing the potential chances of issues from drying whilst printing. One thing I've noticed is when it's unloading, it seems to retract the filament faster than it rotates the spool. This causes the filament to be backed up and ultimately results in the wrap around the spool becoming particularly messy and allowing the filament to become embedded in other parts of that filament wrap. This could ultimately lead to tangles and snags. I've noticed this across a range of different spools, including AnyCubic's own spools, which themselves seem to have different sizes and shapes, so it's not a miscalculation based on spool size. My assumption is this is down to grip. With filament management systems like this, the spool generally sits on two rollers. There's a passive one, which is just smooth plastic sat on bearings, and this just reduces friction as it rolls. And then there is an active one that is connected to a motor, and this is what drives the spool rotation. These rollers need to be grippy to hold onto the thin edges of the spools and cause them to rotate. Whilst they are more grippy than the passive ones, the active rollers still aren't that grippy, and I wonder if it's this lack of grip that's allowing those spools to slip and not rotate at the required speed. This could be because this is a beta unit and that the retail unit will feature some sort of revised coating on these active rollers, but this is what I've got to work with and this is my experience that I'm sharing with you. One last nitpick on the Ace 2 Pro is because of that design at the back, spools are kept with a significant amount of filament loaded into the machine, and even after a print finishes, it's kept at length to increase the speed of startup on its next use. What this means is, if you want to remove a spool, you either need to manually withdraw a lot of filament, which can be difficult to do neatly, or you need to hit the remove filament button on the screen first. On its own, whilst it does take longer, that is sort of understandable. What's more frustrating is, as it's unloading, when the end reaches that first motor, it doesn't stop, it just spits it out. So if you aren't there holding the filament and ready to grab it when it spits out the end, it will allow part of the spools to just unravel. Preferably, this unload process would stop when there was 1 to 5 centimeters of filament left in the machine, allowing you to just neatly remove it. Whilst the filament swap times are similar to that of other systems, the preprint calibration times on the S1 Max are a lot more sluggish. With the bed leveling, flow calibration and resonance compensation turned on, it can be over 16 minutes between clicking print in the slicer and it's starting to lay down that first layer. That's more than twice as long as the preprint calibration times on other similar sized printers with the same calibrations selected. That said, if you're not frequently doing lots of short, sub 30-minute prints, the preprint calibration times are less of a consideration than it used to be. I remember the first time I'd switched to a printer that did any preprint calibration apart from heating and homing, and I was shocked. I'd gone from being able to have an object actively printing within seconds of clicking go to having to wait 5 to 15 minutes before it even started extruding. But I quickly found that the increased speed and print quality that these calibrations allow meant that even though there was a delayed start, the overall print time was significantly faster, and I tend to just ignore how long it takes for the print to get going these days. Now, the very first print I did on this machine was the preloaded 15-minute benchy. Obviously, you don't expect perfect quality when printing with speed as a priority, and from the side perspective, it does look for the most part pretty good. But I was surprised to see several issues of under extrusion and pillowing on the top layers, especially with this being a preloaded showcase print. However, as I say, when speed is priority, there's always going to be quality sacrifices. So as a comparison, I also printed the other Benchy that comes preloaded, with a print time of 40 minutes rather than 15, which did come out much tighter. The first test print I chose I thought would be a good test for both general print quality and also its multicolour abilities. This skull-infused apple showcases overhangs, top surface curves, and 3 different colours. I got it printing and it appeared to be going well, but soon after it began printing the white of the apple, I noticed very severe colour bleeding between the red and the white, causing the white to come out more as a pale pink. Now, I had not played with the settings too much when slicing this, as I wanted to see how well the default settings performed, but it was clear that the automatically generated flush volumes were insufficient. With the flush multiplier set all the way to 3 times, I thought I was getting a clean print, so I let the print run its course. In general, the print came out well. One of these support towers did come unstuck, but the print seemed to recover. The detail of the skulls came out nicely, and even the teeth on some of these smaller skulls are individually recognisable. However, despite the flush multiplier being set to 3 times, I still got a pink colour bleed on all of the layers that feature both red and white. If it's actually flushing the volumes that it states, I'm surprised I'm still getting such an issue here. Whilst there is a little banding on the very top of the apple from the layer lines, I'm actually quite impressed with the top surface quality here, especially on the sloped gradient, so that top surface quality we saw on that 15-minute Benchy isn't iconic of what we can get here. However, if we spin it around to look at the back, there is a spattering of dots and warts of different colours stuck all over the red apple skin, which really ruins the quality and the feel of the print. I had thought that these were from seam positions, but double checking my slice they don't align at all. They are likely from slight oozing from the nozzle when it moves back after a colour change. Even though these can mostly be rubbed off with your finger, there's lines and bleeds within the print beneath some of them. Generally, it's a good print, but with some disappointing issues that let it down. Now, you'll have seen with the prints so far, I've included a time-lapse of the print. Frustratingly, these time-lapses aren't automatically saved to the USB stick you've got inserted in your printer, and they're also not available to be downloaded via the slicer. You can access them by downloading them via the mobile app. Alternatively, you can access them via the printer's screen, for some reason requiring you to first select Start Printing, and then you can go to Video. This allows you to individually select your time lapses and then export them to the USB stick, which you can then move over to your computer. It would be nice to have these automatically saved to the USB stick if there's one present, and to be able to download via the slicer in a future update. Now, I wanted to do some test prints that would test both bridging and also functional prints, so I split this across 3 separate prints. As a simple test for bridging, I printed the suspended filament vortex cube, which both looks fantastic and is a good test to see how well the cooling works and how well fairly long unsupported bridges come out. Whilst the bridging itself comes out really well and looks flawless, there were some issues to note with the print as a whole. The outer wall quality was definitely lacking, displaying problem patches along the sides, though granted I've not printed this on another machine, so I don't know if this is an issue just with the design or the slice settings. But more concerning is the bottom surface of this PLA print is not flat and appears to be warped. Shown here upside down, with the bottom on top to more clearly show the issue. This does seem to have recovered quickly and the top surface is perfectly flat. I'm not sure how well it will come out on camera, but you can see that one corner near the base has compressed layer lines, resulting in a curved base. Next up, we have a simple box with a hinged lid. I chose this to test a couple of things. I printed both the lid and the base in 2 separate colours, but printed them together using the print by object order setting. This was a good way to see that there wasn't going to be any collisions with the nozzle hitting the print whilst it worked. The bar on the back of the box for the hinge was printed with supports, which worked well and came off fine. The hinge clamp on the lid was also printed with supports, which worked well but didn't come off as cleanly. the hinge clamp connected to the bar on the box without a problem. Designs like this are very simple, but if there was an issue with layer bonding, that can cause splitting along the hinge when fitting, and I saw none of those issues here. As well as the box, I also printed a gearbox fidget toy to check that parts would scale and align correctly. The print came out looking good and all the parts slotted together really nicely. It's actually surprisingly satisfying to use. With the multi-gear setup, it takes many rotations of the first gear before the last one completes a single rotation. Obviously, one of the biggest selling points of this machine is its size. With a build volume of 350mm cubed, it's capable of some sizable prints. As a print gets higher, it's more prone to quality defects from vibrations and wobbles, especially as the lower part of the print begins to shrink as it cools. I thought as a test print for the build volume, I'd aim to max out the Z-axis, and ran a print I've been wanting to do for years, printing a T-Rex skull filling the build volume, making this thing 35cm tall in this print orientation. And it came out great. Despite the 0.2mm layer thickness, the layer lines are almost invisible unless getting up close and personal to really look for them. Throughout this 36-hour print, there is no sign of layer shift, the print remained well adhered to the bed, and with a top Z distance of 0.3mm as set by the designer, which sacrifices a little quality for ease, the supports came away without issue. This thing is a literal monster. Whilst the S1 Max comes pre-fitted with a hardened steel nozzle, especially if you're using more specialist materials, it is eventually going to wear out and need replacing. And even if it's all running fine, you may just want to swap to a different size nozzle. This machine has an interesting design for swapping out the nozzle, featuring a spring-loaded heatsink that splits in half. Not only is it a completely tool-free workflow, but because you're basically only swapping out the nozzle itself rather than the heatsink, thermistor and other components like in some other modern printers, the replacement nozzles are significantly cheaper. Other than a couple of hiccups and nitpicks, it's been a fairly positive video so far. But it's not all been plain sailing, and there is a range of issues and frustrations of various severity which I've experienced, some of which may be down to teething issues or the fact that this is a beta unit and will hopefully be rectified by the time it's released, but I need to address all of my experiences and the issues I've had in this video. All of the test prints I showed earlier were in PLA, but one of the things that the S1 Max brings to the table over its predecessor, the original S1, is active chamber heating, making it much more capable of printing engineering grade and specialist materials. So I ran a couple of test prints using AnyCubic's polycarbonate filament, PC, to see how it performed, and this is where it really started to go downhill. For my first PC test print, I decided to go with these cool print-in-place gear hinges. These would be a good test of functionality, overhangs, and bed adhesion. This print failed partway through, seemingly from bed adhesion issues. The bed also showed very slight scarring from the nozzle on a single line from one of the initial moves. This was despite having run the pre-print bed calibration, but I then ran a full calibration again just to be safe. I tried checking these settings in the slicer again using AnyCubic's recommended settings for their own PC filament, which I was using. I sliced it again and printed it again, twice, but both times it failed earlier than it had that first time. After checking over the printer to make sure it looked okay, I decided to try a different print with PC. I decided to use a model that was simpler with a large flat base for better bed adhesion. I decided to print a phone case. I watched the print closely as it started and saw that despite having run the auto bed leveling as part of the pre-print calibration, it was evident that parts of the print were being printed much closer to the bed than others. After ensuring that it was printing without further issue safely into the second layer, I moved into a different room, but continued to monitor the print using a live feed via the slicer on my laptop. A little while later, I suddenly saw that the front of the extruder carriage was sat on the print bed, so I immediately clicked stop in the slicer. The slicer popped up a message saying that the print had been cancelled. But it was evident from the live video feed that it hadn't been cancelled and it was continuing to print. I hit stop again, twice, and both times the same thing happened. The slicer told me that it had stopped printing, but it hadn't stopped printing. For reasons I've explained in previous videos, I'm not so quick on my feet, which is why I was prioritizing trying to stop via the slicer rather than running straight back to the printer. But after a third failed attempt at stopping via the slicer, I did quickly make my way back to the printer, and luckily, when I hit stop on the printer itself, it did actually stop. I find it pretty alarming that the stop command was not being sent from the slicer to the printer, despite the slicer telling me that it had been stopped. There was definitely a good data connection between the two because I was still receiving a strong live video feed from the printer on the slicer. After the print did stop, as may be expected, the extruder head ran to the end of each axis before returning to sit over the purge chute, but it very much sounded like it was trying to run beyond each of the end stops. Looking at the print, there is a 5 to 7mm layer shift just a few layers in, and it seems to have failed soon after that. It looks like a failed part of the print caught a fan guide on the extruder cover, and that's what pulled it off. I mentioned that as I was watching that print start, I could see different areas of the model printing closer to the build plate, but as I look at the bed now, I can see several points where the nozzle lightly grazed the build plate during moves. This could suggest that it's either not leveling the bed correctly or it's not running efficient Z-stops, but more on this in a little bit. As this issue became more apparent when I'd switched to PC, I should point out that I did effectively flush through the nozzle before switching from PLA to PC, and this reel of PC was effectively dried before use. Now it was time to check the printer again, and at first everything looked okay. But pulling off the silicone sock, whilst the end of the nozzle had looked clear, there was a massive backup of PC in there. I had to heat up the nozzle and remove some polycarbonate before I could even open the nozzle release clasp. So I finished cleaning up the mount and fitted a replacement nozzle. I then ran a couple of benchy prints in PLA and they came out no different to the original ones. I mentioned before about the Vortex cube not having a flat base, something I had put down to warping despite this being in PLA. The reason I hadn't considered it being a hardware issue is I'd already printed the box, which has large flat surfaces which do appear to be flat. However, as I'd printed the lid and the base at the same time using print by object, they weren't centered on the bed and therefore they were in different sections of the bed to both the Vortex cube and both PC prints. Now there have been quite a few reports online over the last year of people with the Kobra S1, the smaller brother of the S1 Max, saying that the beds aren't flat. A little bit of variance in the beds in modern printers usually isn't too much of an issue, as the pre-print bed mesh calibration probes the bed and adjusts the print for any deviations. However, the issue here, I believe, is from the rigidity of the bed and the method of probing. When performing this calibration with the S1 and the S1 Max, it uses a pressure-based probe where it gently pushes against the print bed at different points with the nozzle and detects resistance. This issue occurs when there is warping or misalignment on the bed, especially in the rear two corners, and when the nozzle pushes down to probe the bed, it actually pushes the bed slightly and gives inaccurate readings. Some other printers use different methods of probing, such as an induction probe where it can detect the proximity or immediate contact with a metal build plate without having to push down onto it, but this method is used on a wide range of printers. It becomes an issue when the bed is not solid enough and it can flex under any pressure that is given to it. If I just gently push on either of the back corners of the bed, you can see the bed flexes quite a bit. This suggests that either the bed is flexing under the pressure or the mounting points are providing an excessive amount of give, either way contributing towards inaccurate results from mesh bed leveling. Now, whilst there are potential fixes and workarounds for this, and it hasn't affected everyone, this has been a known issue for months with the S1, so the fact that it still exists with the S1 Max, a brand new product, is not a good sign. An important thing to note here is that, as I mentioned earlier, this is a beta version of this printer, and so it could in theory be using older or more experimental parts or components. However, when I was sent it, I was also detailed the differences between this beta version and the retail version, and the only hardware difference that was itemized was a dust cap for the top of the rear lead screw. Other than the issues I've mentioned, I've also experienced a series of error codes at the point when I'm starting a new print. It's not something that causes an issue mid-print, but it means that I have to start the print over again. I have raised this with AnyCubic and they've told me that this is a result of the beta firmware and that it won't be an issue when the retail version is released. Since the issues with the polycarbonate prints, I've had several back and forths with AnyCubic, hoping to find some sort of cause of the issues or a solution. Ultimately, they've decided that they think that this specific printer is defective, possibly through shipping. That scenario could definitely be the case. When it arrived, the box did have damage on the side and evidence that it had been mishandled whilst being shipped here. I also know that there's several others out there that have been trialing the same version of this printer as me and haven't experienced some of these issues. So it's difficult to say how much of this is a result of this being a beta machine, how much is down to it being defective or damaged in transit, how much is down to software which will hopefully be patched in the future, and how much is representative of what this machine is actually like. AnyCubic seem to be very confident that this is an isolated incident, and that they've told me that when available they will send me a retail version of the S1 Max. If they do, when it arrives, I'll do a follow-up video to this, where I'll see which of the issues I've demonstrated today have been rectified, either with the retail hardware or with software updates. Now, I'm not brushing any of that aside, and we'll be back to it in a second, but first, in a world where multi-nozzle, multi-extruder printers are becoming increasingly common, allowing multicolour prints with zero purge waste, it can become increasingly difficult to justify the purge waste produced by a single nozzle printer. So as a result, if you're planning on doing a lot of multicolour or multi-material prints, if your budget can stretch, looking at a multi-nozzle or toolhead nozzle changer may be a better direction for you. Now, the direction I was planning on taking this part of the video in has changed a lot over the last month or so. When I first started using this, I was surprised how impressed I was with the build quality and the design of the S1 Max. It is a great looking printer and it has some really interesting and generally well thought out implementations. It's obviously got the potential to be a very capable printer and I've got some great prints out of it. So I'd initially been planning to summarize this video with something like this. If you want a large build volume and are primarily looking to do single color prints, but want the ability to occasionally do multi-color, multi-material prints, the AnyCubic Kobra S1 Max cannot be beaten for this price. However, when purely based on my own experience, as much as I'd like to, I cannot currently recommend this printer. Some of these issues may be down to it being a defective beta unit, and many of the other issues will hopefully be able to be patched with future firmware updates. But I'm here to give you a factual account of my own experience, not my hopes or expectations. So, as a roundup, the Kobra S1 is a beast of a machine that packs a lot into a smaller package than many others. It boasts a lot of the quality of life features that are otherwise reserved for more premium alternatives, but at a more affordable price point. With a range of filament drying functionality, a relatively compact form factor, quick and easy nozzle replacement, and super quiet operation. But with my experience, that comes with the caveat that it also suffers the performance and reliability issues that I've covered in this video. Whilst for some, depending on your use case, many of the issues that I've covered today won't affect you, and this could be a great printer for you even in this condition, especially if you're happy to do some occasional problem solving in exchange for a cheaper price point, if you were considering the Kobra S1 Max, I would maybe hold off until there's some reviews of post-release units. I know that there is a great many of you who have had solid experience with AnyCubic printers and swear by the performance and reliability, and that is great to see. But what I can do here is speak to my personal experience with this specific machine. If you've got an AnyCubic machine as your trusty workhorse, or if you've got one and you've had a similar experience to me, I'd love to hear what you've got and the experiences you've had with it, so pop them in the comments below. As I mentioned, if AnyCubic does send me a retail version of the S1 Max, I will be producing a follow-up video seeing how that compares to my experience with this one, so keep an eye out for that. In the meantime, I've got an exciting and slightly different video coming soon, in which I'll be venturing out to give you an exciting and intriguing insight into an innovative company that I have no doubt you'll enjoy. So keep an eye out for that and subscribe so you don't miss it. As always, thanks very much everyone, and until next time, happy printing. Thanks everyone for sticking around, and a huge thank you to my revolutionaries, my channel members, for your support. If and when it is published, I'll pop my follow-up video here. Otherwise, why not pop on one of my other videos to learn something new or have some fun. Thanks very much everyone, and until next time, happy printing.